Hello everyone, welcome once again. So now we have log x in base 4 plus log x in base 5 equals to 6. So we are to find the value of x. Now, for the purpose of neat workings, I'll be writing some notations here in this workings place. Now, I would like to express this 2 as what? As this by recalling that log AB is equals to what? Is equals to log A all over log B. So now, before we can solve this one conveniently, we are going to what? Express this in form of this. Why? Because this is also equals to this according to the logarithm principle. So you need to recall this. So now by following this principle here, we can express this one as this form. So this our x will represent A, then this our 4 here will represent B. So now let's solve for that. Then we have log x over log 4, then plus this one, the same thing. Our x will be A, then our 5 will be B. So we have log x over log 5, which is equals to 6. So that's what we get now. So now there is a trick we are going to do here, which is using the factorization trick. So now, you know that we have log x here, we also have log x here. So we can factorize log x outside. So if we want to factorize it, we are going to do this. We are going to do this way. We have log x, then open bracket. We now have, so since we have factorized log x outside, we now have 1 over log 4, then plus 1 over log 5, and close brackets, which is equals to 6. So now, we then have what? So this is log 4 and log 5. We are going to find the LCM. So the LCM will be log 4 dot log 5. So now, we now have log x, open bracket. Now, so the LCM of log 4 and log 5 is what? Is log 4 dot log 5. Mind you, this dot here represents multiplication, not decimal points, okay? So now, we are going to use this according to the principle of resolving of a fraction. Now, so this one now, this log 4 dot log 5, we are going to use to divide this log 4. If you divide it with this log 4, we will get what? Log 5. Log 5 multiplied by 1, we have log 5. So you have plus. Now, so we are also going to use this same in this our LCM, this one to divide this also. If we use it to divide this, what we left with? We will be left with log 4. So log 4 multiplied by 1, we have log 4. So which is equals to 6. In resolving this, we are going to apply a principle of logarithm here. Now that principle we are going to record as what? Recall that now if we are having log A plus log B. It is also this equals to log open bracket A dot B. Okay, so now we are going to have log x open bracket. So we are applying this principle here now. So we will now have, so this our 5 will be our what? A. Then this our 4 will be our what? B. So therefore it will become, so instead of writing this, we are going to write it as this, in as much they are equivalent to each other. You get that? So now we now have log open bracket 5.4 and close brackets. So we now have all over log 4 dot log 5, which is equals to 6. So I've explained earlier that this point here represents multiplication, not decimal points. So now we have log x open bracket log 5 times 4 give us 20 all over log 4. We have log 4 dot log 5 close bracket, which is equals to 6. So now there is a particular trick we are going to do here. Okay, so that trick is, we have this log 20 is dividing both this and this. Okay, so we can also express it as this. So for you to understand what I'm saying, we can also express all this as what? As this. We can express it as log x open bracket 1 all over log 4 multiplied by log 20 all over log 5 close bracket equals to 6. So writing it as this, we are still correct. Okay, multiply both sides by as log 5 all over log 20. So we are going to multiply both sides by log 5 over 20 in order for us to what? To simplify this better. What we are looking for is x. Multiplying both sides by log 5 over log 20, we get this. Okay, so now this we cancel this. Why this? We also cancel this. So we'll be left with log x open bracket 1 all over log 4 close bracket equals to 6 dot log 5 all over log 20. So now what we are going to do is this. So this log x is multiplying this one. So we will now have what? Log x over log 4 is equals to 6 dot log 5 all over log 20. Okay, so now we are also going to follow this same principle here. Now, So instead of writing it like this, we can express it as this. So this our x represents what? A here. This our 4 represents what? B here, because you are expressing this one as is the same to this. Okay. So now instead of writing it like this, we can still write it as what? As log x base 4 is equals to 6 dots. Now, the same thing we did here, that's what we are going to do for this. By following the same principle, we now have log 5 base 20. Okay. So also now, to simplify this now, there is another principle we have in logarithm. We are going to record that one too. Recall that if log xa is equals to b, then what? Then x is equals to a raised to power b. So this is one of the principle that if log x over this is equal log x base a equals to this is equals to this x is equals to what? A raised to power b. So that's what we are going to do here. So now we are going to have our x to be equals to 4 raised to the power 6.6 dots log 5 base 20. Okay. So now we can also solve further by saying our x is equals to 4 raised to the power 6 log 5 base 20. So therefore our x is equals to, so you can as well leave it as this, and you can also simplify it further. You can leave it as this, you can also simplify further to this, and also you can finalize the answer as 4 raised to the power 6 will give us 4096 raised to the power log 5 base 20. So this is the final answer. Thank you.